This is the 8th update on my attempt to install a 1996 Volkswagen TDI engine into a 1997 Subaru Sambar K-van. I'm not a real mechanic, nor am I a fabricator. I'm an average Joe with some cheap tools and a space to work. I've already made several mistakes, and I'll probably make more. No secrets here. If I mess up, you'll hear about it. But we will get into what progress has been made in a few minutes. First, let me take you on a tangent. I've been using a product named POR-15 for a few years now. I'm aware there's a significant pushback on the internet regarding the quality and effectiveness of this product. It has occurred to me that now is a good time to review the condition of the POR-15 on this vehicle and share a video on said condition. Approximately 2 years ago, I applied this product on many parts of the undercarriage on this van. I did a very modest degreasing step before applying it, meaning I sprayed it with mean green degreaser and then pressure washed. I should also provide some background on the environmental conditions this chassis has been exposed to since the application of POR-15. So let me cover that first. First of all, the coating is about 2 years old. Second, the weather conditions. Well, this van stays in Alabama, which has an average humidity in the high 60% range. It's driven almost daily, rain or shine, and it's been driven in snow exactly once, think salt, and it's generally parked overnight indoors, maybe 80% of the time. I've used this product on 4 vehicles so far, and my results have been more or less consistent with what you see here. Additionally, I've only applied it over newly cut or exposed metals or lightly rusted metals. None of the applications I've done in places where rust was flaking off or super heavy. That's to say, I can't speak to the effectiveness of this product in those situations. I've been around the block enough times to know better than to reject other people's experiences, so keep that in mind. I believe others when they say they've not had good results, and both their experiences and my experience can be valid at the same time. So what have I experienced? The POR-15, has peeled off places where paint beneath it was not fully bonded to the metal. For example, spray paint, places where the prior owner of this vehicle applied spray paint, the POR has peeled off in those spots. In places where there was light rust, I have not experienced any peeling or lifting, and I have not seen rust break through or reappear. I have experienced moderate fading in places most exposed to the sun, which in my case would be the wheel wells. I have not used any UV protective coatings, which POR-15 does recommend. So what you see here is just the gloss black POR-15 paint after a couple years of service. When I weigh the cost of the product and the difficulty to apply against the results I'm seeing, I plan to continue using this product. I do think they, the manufacturer, have put themselves in a position to catch some hate by overpromising in their marketing. It is my opinion that one is fighting the laws of physics when trying to make a coating stick and adhere to a layer of material that's not fully and securely attached to the metal itself. Sure, it'll stick to a millimeter of rust, but will that rust stick to the metal beneath? Don't bet on it. So there you have it, my opinion and my report on POR-15. Now, on to the update of installing a Volkswagen turbo diesel engine into this K-van. Last update, you saw the old powertrain was out and the mock-up process for the diesel engine had begun. The floor of the van had been cut to make room for the new powertrain. I cut the stock crossmember, added some material to it to extend it in hopes that it will hold some of the engine mounts for the diesel. My last update had me waiting on engine mounts and additional steel needed to fabricate the rest of the mounting system. Oh, and updates will be every other Tuesday going forward. I'm just too slow for weekly updates to be feasible. So what did I accomplish in the last 2 weeks? Far less than you might expect. I eventually made decisions on how to arrange the support system the powertrain will be mounted to, and progress was made building it. My cheapo welder died, leaving me no choice but to dip into the paint and body budget to replace it. The silver lining of that little snafu is the $330 welder I bought to replace the old Harbor Freight unit is a far superior device for a hobbyist slash hack like me. Seriously, this device is giving me some confidence. It has far more adjustments, but it also has a setting called Synergy that's great for someone of my skill level. Basically, it lets you set the wire feed speed and it automatically matches the power settings for you. It made a meaningful improvement in the amount of time it took me to weld up the support system. I had become desensitized to how long I was spending fighting with that old welder. My decision is to build a cradle which relies on the original connection points of the Subaru powertrain, namely the rear crossmember and attachment flange on the mid crossmember. That mid connection point is also the structural support for the rear suspension. Now, this may be a no-brainer, but I had to spend a lot of time trying to visualize all the options before concluding the original connection points were the only viable option. In hindsight, I don't know why. Once again, I had to wait on tools and parts. Some things I did not know I would need. Other things I could not be sure of until I completed some other small thing before it. This video will only cover the mounting cradle and the engine mounts, but that's actually a pretty big part of the entire project. I chose 1-inch outside diameter mild steel pipe for the powertrain cradle, mostly because mild steel is the only material I am confident that I can weld securely. The wall thickness is 1/8 of an inch, and I hope it is sturdy enough. The material I chose is also DOM tubing drawn over mandrel. So I have the engine on the wooden cradle sitting on my table. The modified rear crossmember is bolted in place and the powertrain is placed in the location within the engine bay I expect it to live in. I'm starting the mock-up of the 2 longitudinal support pipes that I will be installing. I'm finding that the wooden cradle I built will be in the way of placing one of those tubes, so the cradle will have to be cut and modified. I really struggled to figure out how to hold the engine in place while establishing the layout and marking the connection points. More on that will come later. The general plan here is to have one longitudinal bar connect to the modified rear crossmember, cross under the powertrain just to the right of the transmission adapter plate, then connect to the original transaxle mounting point. Then a second pipe will run under the front of the engine near the accessory pulleys, turn about 75 degrees inward, then join the first pipe in connecting to the original transaxle mounting point. So this plan results in 3 mounts to support the powertrain's weight vertically. Then I can evaluate whether a horizontally oriented mount is needed. And once those items are resolved, I will plan and install a torque damper to deal with the rotational forces of the engine when it's under load. So there will be a vertical support mount here on the original Sambar connection point, and there will be a second vertical support here near the front right of the engine, which will be mounted by a modified attachment point low on the old crossmember. A third vertical support will be on the left side of the engine, outside of the view of this video. More on that later. As I was preparing to fabricate a bracket for this mounting point, I found out I was going to need to retap the threads. In fact, I ended up needing to retap practically all the threads on the block. Rust and time had made a mess of these threads. For anyone this might help, the castings in this block for mounting points are all M10 bolts with a 1.5 thread pitch. Here is a clearer view of where that first support beam will go. Once I felt confident that I had it in the right place, it was time to tack weld it to hold it in that place. Now here's the second support bar welded into place. I concluded I needed to strip off a little bit more of the POR 15 to be able to widen the welding area. And shortly, I'll add a plate right here to strengthen the connection of this pipe to the cross member. I cut that bracket out of some surplus 16th inch sheet steel I had left over. I assume time will tell if this was a good idea or not. Next, it was time to cut and bend a third pipe for the powertrain cradle. The idea here is that this cross member will provide a platform to support an engine mount near the front of the engine, up front near the accessory drive belts. I welded that bracket in place to support the first pipe. In order to match the powertrain cradle to the existing transaxle mounting point, I needed to make something. As you may remember from previous videos, that mount was damaged. The rubber was ripped, and even if it wasn't, the stock mount would not be able to handle the new design. The weight of the VW powertrain is significantly higher, and additionally, this weight will be shifted forward when compared to the stock Sambar power plant. I bought 4 of those rubber bushings that you just saw because I anticipated damaging the first 2. I wanted them to be in place when I tack welded the loop to the frame so that I was less likely to make an error in measuring. The heat did damage those bushings, but after all the welding was done, I just put in 2 new ones. I thought it would be helpful later if I marked the cradle where this axle centerline falls. I was right, it did come in handy later on. Then I turned my attention to making the forward engine mount. This one will have very little clearance over the axle shaft due to the inverted transaxle. I installed the Volkswagen axle coupler to help me make sure that what I built would clear the axle. It needs to have additional room because as the van hits bumps, the axles will move up and down relative to the powertrain. To help me drill the mounting holes in the right place and at the right spacing, I put some paint on the bolt holes and pressed the plate into position. It left witness marks that I used to drill the M10 sized holes, and it worked well in this instance. I mark my lines on the plate to capture the limits of space that are available without hitting anything. If I keep my vertical bracket within these lines, I won't hit the oil dipstick, the crankcase vent tube, or the axle itself. Here I am working to visualize where the forward engine mount will need to attach and marking it for future reference. An additional tube will connect just to the right of that X to strengthen both the joint to the left and to distribute the load a little more evenly on the front mount point. Next, I mark and cut the plate which will become the platform for the forward engine mount. And with the plate cut, I tack welded it to the cradle and went to work bending things to achieve level. This is my first draft for the perpendicular portion of the forward engine mount. As I would later realize, I did not make it tall enough. The engine mount I plan on using is pretty tall, so this will need modification later. So I welded up this mount component while trying to keep it 90 degrees perpendicular to the base plate. I'm going to wait until I have more usage of this new welder before I give you my opinion on it, but you'll get my thoughts eventually. What I ended up with does clear all of the things that I was concerned about, but as I mentioned previously, it will need to be modified. Now that I have the cradle dimensions right and I have the axle center line marked on that cradle, I can start putting the powertrain and the cradle together. I need to do that so I can fabricate and weld the last parts of these engine mounts with the engine in the right position within the cradle. To make that work, I want to have the wooden dolly I built sitting on my yellow lift table, the cradle resting on top of the wooden dolly, and also the powertrain resting on that wooden dolly. I am too big and old to crawl around inside a K-van engine bay which contains a 1.9 liter engine while effectively welding parts. So the only viable option for me is to get this right with the powertrain and the new cradle out of the vehicle, then lift and bolt those items in a single lift into the engine bay. So as the powertrain sits on the wooden dolly right now, the angle of the system is what I want. I'm taking some measurements at different places so I have a reference showing the degree of angle, and after I put the cradle under the engine, I will check to see if it's still what I want. And that's it. That is all I accomplished over the course of 2 weeks. I keep spiraling into analysis paralysis. I spend a lot of time thinking about what I need to do, and sometimes I visualize it 6 or even 8 times before I realize that I did in fact actually forget something. And that makes me more timid. I start all over the process of thinking about something 6 or 8 times. It's just kind of a feedback loop I'm stuck in, and I'm not making progress nearly as quickly as I'd hoped. My assumption was that I could do this in 3 to 4 months, but it's already been 5 months. My assumption is that at my best pace, it's going to take another 2 months or even more. I have an even deeper respect for those who have done this sort of thing before me, and ultimately I hope this swap is worth it. I'll post another update in either 2 or 3 weeks.